Hello and welcome back to a new episode of Kass podcast. If you are an old listener to the podcast, you might be wondering why am I talking in English? Because the podcast is usually in Arabic or Moroccan language. The reason is that I'm trying to test a new form of episodes where there is no video, just audio, and also on YouTube an audio visualizer. And I will be talking alone with some or about some technical subjects, and using Arabic would be a little bit an overkill, and English is the more appropriate language to discuss these subjects, like today's subject, which is clean code. We will talk about a lot of things, and hopefully you will learn something. If you are on YouTube, don't forget to click like and subscribe to Lectorem channel. If you are on another audio platform like Spotify, Google Podcasts, Apple Podcasts, and others, don't forget to give your rating to the podcast. If you are on another website and you are listening to this podcast from another website, don't forget to visit my website sliman.io, and let's go. Before we start, I have some quick disclaimers. The first one is that this is not a replacement of the book. If you have access and time to read the Clean Code book by Uncle Bob, go read it. It's going to be a very helpful resource. The second disclaimer is that I will ignore some details that I don't see as crucial for writing a clean code in 2021. And as Simon Sinek says, we should start with why. Why we should remember the clean code principles. I had a story with a colleague, I think 1 year ago, and we had some argument. I wasn't part of the argument, but I saw this argument, and this colleague of mine, he's a friend, he was arguing that function, because we were in a code review, and he wrote a function, a long function. I'm talking about at least 70 lines. It was hard to understand, and he was arguing that a function should do one thing, and that is a clean code principle. That's wrong, because if you really are using clean code as a resource, in the same book, there is that functions should be at max 30 lines and should be small. So sometimes with time you forget what is the principle, and you just have some slogans for no reason. And also sometimes there is changes and technologies and programming languages that pushes you to forget about clean code principles. So if you passed from, for example, Java to JavaScript, it's gonna be a little bit harder to apply the same principles that you've learned in Java to JavaScript, because when you are beginning on something, you don't have that ego that you have it when you are familiar with the language and the technology. And also there is new patterns, there is new programming patterns, and you have to remember these principles from time to time, even if you are a senior software engineer or a senior developer. And in the book, there is this kind of knowledge and work, and Uncle Bob says that there are two parts of craftsmanship: knowledge and work. And this applies for almost anything when we talk about craftsmanship. So if you are a guitar player, yeah, you can listen to guitar players, you can read books about playing guitar, having courses, but if you don't use that knowledge and apply it while you are practicing your chords, you will lose this insight. And this is the most important thing. Combining work and knowledge is one of the fastest ways and tools that you can use to boost your learning process. Okay, let's start with the first part in the book, which is what is clean code. In the book, Uncle Bob answers or asks some big names in the software industry to give a definition of the clean code. And we have here some very big names like Kent Beck, the founder of Extreme Programming, Martin Fowler, Ward Cunningham, Ron Jeffries, and of course Bjarne Stroustrup. I hope I'm pronouncing his name correctly. He is the author of C++ programming language. So very big names, and there are some repeated points about clean code, whether it's simplicity, meaningful naming, having tests, no duplication, and so much more. So in the book Clean Code, Robert C. Martin, aka Uncle Bob, presents his detailed definition of what is a clean code. And the first part of the book, or the first chapter, is meaningful name. So after every chapter, I will just set or give the points that are in the book with examples. So in the meaningful names, we have the first one is used intention revealing names. So the name of a function, a variable, or a class should tell why it exists. So why a function or a variable exists should be told just using the name. And the name should not require a comment to explain it. If you add a comment to explain a name, it means that you don't have a meaningful name. So instead of using int n, it's better to use int input size. The second point is avoid disinformation. So for example, if you use account list as a variable name in Java to refer to an array of accounts, it will be misleading, because the word list refers to a specific interface in Java. The third point is make meaningful distinctions. Sometimes programmers write code just to satisfy a compiler. I have a story with this. I had a dear friend of mine in college, and we were working on a project, and he named a class using K. The reason why he named it class using K, just to avoid compiling errors, because class with C is a special keyword for the compiler. But the problem here is not the compiling errors. Why would you think about naming your class a generic name like class with K? Normally, you will use a meaningful name, and you have this kind of distinction between the class as an entity of the programming language and your class or your entity. So that's another thing about the distinctions. The fourth point is use pronounceable names. This matters because if you don't use pronounceable names, you will cause problems for other co-workers. And programming actually is a social activity. If you are part from a team, you don't program just for yourself. And even in the open source community, there will be people who will check your code, there will be people who will read your code, and there is code reviews and all that stuff. So you have to use pronounceable names because people will refer to parts in your code. Another point is use searchable names. That's very important because you can't grep or make a command F for IDE fanboys. You can't grep or make a command F for single letter variables. That's why longer names is very better than shorter ones. And the competitive programmers have some hard time following this rule. I've had some really competent competitive programmers and who are also software engineers in the podcast before, and we talked about this point. And yes, this is a very valid point. When you are a competitive programmer, normally you are used to code under time pressure, and this can push you to develop a bad habit of giving names to your variables, your functions that are not meaningful. So you use N, D, V, B, and yeah, that's practical for a coding competition. But when you pass to a professional world, you will have a hard time doing this, because people will need to search for something in your code. And also for constants, instead of using constant like 256, you might be better off by using a constant and assign it to a variable like max size or something like this. And like this, people will, or yourself, you will be able to search for it. Otherwise, you will have a hard time, even yourself, because you will, the most the most probable person that who will revisit your code is yourself. So yeah, you better make sure you make yourself you make your code searchable. Another point, when we pass to classes, there are some recommendations in the book. A class name shouldn't be a verb, and also classes and objects should have noun phrasal name like customer, wiki page, account, and other sparse and like this. And also you have to avoid words, generic words like manager, processor, data, or info, because they are too generic. And we will talk about single responsibility principle after. Another point for methods and functions, it's the opposite. Methods should have a verb or verb phrase, like you have post payment, delete page, save something, or something like this. Also, another important point is that you have to pick one word per concept and stick with it. For example, it's very confusing to have get, fetch, and retrieve as equivalent methods for different classes. If you have get, use get in every class. If you have fetch, go with fetch for every class. So having this multiple, it will make your code very hard to reason about when you have multiple classes. This is very important. Another one is use solutions names. Here, what the author meant by solution names is using some technical concepts. So your coworkers are programmers, and you can use, so because they are programmers, you can use computer science terms, algorithm names, pattern names, math names. So you have this kind of a vocabulary that is shared between programmers. For example, instead of naming a class Bell's static generator, you can just name it Bell's factory. And the term factory refers to a design pattern that is known by almost every programmer on this earth. The last point in naming is add the meaningful context. So to get, usually a name doesn't have a meaning in itself. It has to be in a context. So to get meaning from a name, you need to place it in a context. And an easy way to do this is just adding a prefix. So for example, if you have a function called state, if you have an argument of a function that is called state, this name means a different thing for different people. So the state for someone in the front end chapter or the front end side, it means something related to the state of the app, like it is used in React or Redux or Angular or something like this. But the state for a backend developer is not the same, has not the same meaning. To avoid this, you can add address state. So here we refer to the state in the context of address. So the state of the address means the same thing for a backend engineer, for a front-end engineer, for a DevOps guy, for everyone. And this prefixing will add meaningful context to your name. Now let's talk about functions. Functions should be small, and as Uncle Bob said, the first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that. In the book, Uncle Bob's recommends that the length of a function should be at max 20 lines. There is also another point, which is blocks and indenting. Here, the recommendation is that every if, else, and while blocks should be 1 line long, and that line should be a function call. This is a little bit hard to achieve, but it is very, very helpful to make your code very readable. And the functions like this wouldn't be long enough to hold nested structures, and like this you can read and understand functions very easily. Another point, which is do one thing. Uncle Bob said functions should do one thing, they should do it well, they should do it only. Of course, the problem here is that how can you identify this one thing? So if you have a system for let's say payment, and you have a function to handle everything, a function of 3000 lines of code here. Yes, the function does one thing, which is the payment, but of course you can divide it. And a way to know that the function is doing more than one thing is if you can extract another function from it with a name that is not merely a restatement of its implementation. Again, if you have a function and you can extract another function with another name, a different name, which is not a restatement of the name of the function that you are examining, here this function does more than one thing. Also, the name can tell if you have a function of create and start HTTP web server. It means that, of course, the function does more than one thing. It creates an HTTP server and it starts an HTTP server. So here, you can tell that the function is doing more than one thing. Another point, which is one level of abstraction per function. Sometimes, let's talk with an example. You have, for example, a function f, and this function is called from another function g. But in the function g, you write some code that has the same level of abstraction as the function f. So let's repeat. You have a function g. This function g calls another function f. But under f, for example, you create another code with the same level of abstraction as f. Here, you shouldn't do it because it's a little bit confusing. The best way that you can handle this is that this code of the same level of abstraction as f, either you include it inside f if it's one thing, or you create a third function h that encapsulates this logic. Like this, you will have g calls f, and after that calls h, and it won't be confusing. It will be easily readable. The fifth point is that reading code from top to bottom, or what is called the step down rule. So you want every function f to be followed by other function it calls. Like this, you will be able to read the code like a newspaper article in DFS manner. So for example, if your main function creates or calls three other functions, for example, let's talk about an HTTP server. So you have create logger, and after that a call to create router, and another call to start server. In the function create logger, you call other functions, build logger and connect output. So here you should have the code of the two functions, build logger and connect output, directly under the code of create logger that is called from the main. The worst thing that you can have is that you have the code of create logger, and after that the code of create router, and after that the code of create of a start server, and after that you will have the code of build logger and connect output. This is the worst thing you can have, because you cannot read code very easily. You will have, okay, we will examine create logger, and after that in create logger you see calls to build logger, but you cannot find its code very easily. This is, of course, we are talking that the code of these functions are in the same file. Another point, which is use descriptive names. Here you should not be afraid of using long names. I see this multiple times. Most people are afraid of using long names, and yeah, for example, like I said, when you are working under time pressure, and this is not usually in the professional world. Usually, either you are on a coding competition or in a coding interview. And in a coding interview, there's a hack that is stated by Gailey, I think, the author of Cracking the Coding Interview. It says that if you are on a coding interview, you start creating a variable using a variable name, but you make sure that your interviewer is aware that you will be using a shortcut. So for example, you will have a variable name like I don't know, file serializer. You will create this as a variable name, and after that you will tell your interviewer, I will use fs as a shortcut for this variable, because it will take more time and more space using a whiteboard to write this name of file serializer completely each time. Also, I see this also in Golang code. The instance variable usually is in one word, one character. It's a little bit confusing. So, for example, when you have let's say a tree class, and you have a function add a child, you will have the instance name is t. It's a little bit confusing. It's better to use tree, and this, of course, we are talking in a professional environment, not in a time-sensitive environment. Also, now we will talk about function arguments. In the book, the Uncle Bob recommends that the ideal number of arguments for a function is 0. Next comes 1, and the max that he can accept is 2. 3 arguments should be avoided where possible, and 4 arguments should be dropped altogether. I can relate to this because there are 2 issues with multiple arguments. First, the code that calls your function might mix the order of arguments, especially if we are talking about the same type. For example, if you have 4 inputs and all of them or 2 of them are string. So it's very easy if you don't have a very complicated IDE that the colors of your function will mix the order. So instead of giving you the first name, last name, they will give you the last name and first name. And also, if you have, for example, 2 parameters that implement the same, or 2 arguments that implement the same interface. And even worse, if you are talking about untyped language. So if you are on JavaScript, it's gonna be a very very hard situation, because in JavaScript you don't have usually this code check-in, and you might have this code on production. It will be hard. The second issue with multiple parameters is that but you will have a hard time testing them, because you will have to find the different combinations. If you have 4 parameters, good luck with that. You will have to test all the combinations of arguments, and it's not a good thing. But if you need, sometimes, of course, and most of the times, you need to pass multiple arguments, you can use what is called in a data structure a dedicated class or an object for it. It's called, for example, in Kotlin, I think it's called a data object. Also in Java, it's Pujo, plain old Java object. This object will wrap these arguments, and usually when you have multiple arguments, you can find a relation that relates them. So if you have, for example, you have a function that should accept 4 parameters: first name, last name, and I don't know, address, zip code, and whatever. So it's clear that you can group this in a class called, for example, customer or user or something like this. And yeah, that's one way that you can avoid using multiple arguments or params. Also, this applies for return value. For example, usually it's for example for Golang, it is allowed that you can return multiple values from a function. And for me, I think this can be overused, and you can have a very, very nasty code and very hard code to test. And usually I try to keep it 2 outputs or 2 values per function, and I try to always make sure that the second value is an error type. But if there are more than that, I would create a struct or something like this that groups all of the return values, and like this I can avoid this problem with output values. Another point in the book, which is flag arguments. Flag arguments, we are talking about a boolean that you pass as an argument to a function, and based on that argument, a function creates or calls on other functions or have some logic. Uncle Bob said that flag arguments are ugly because they are indicating that the function is doing more than one thing according to the value of the boolean, if it's true or false. Another point is that you should have no side effects. So side effects are lies, because your function is promising to do one thing, but it also does other things. For example, if you have a function called create HTTP server, but in the code of that function, it's not just creating an HTTP server. It creates the HTTP server, and after that it starts the HTTP server. And this is very common when it comes to backend or backend for front-end code. Usually you should, because this is a side effect. You are promising just to create the HTTP server, and under the hood you are starting an HTTP server. What you can do is you can extract the logic of starting an HTTP server into another function, and you will have create HTTP server, and after that start HTTP server. But the possibility that most people or some people do is that you can name the function create and start HTTP server, but this violates the do one thing principle. So if you have a function that creates and starts HTTP server, even if it's indicated in its name, it means that this function is doing more than one thing, and you should not write functions like this. Now there is another pattern which is command query separation. This is a very useful pattern, and they said that functions or components in general should either do something or answer something, but not both. So your function should either change the state of an object, or it should return some information about the object. So for example, the getter is getting an information about a subject, so it's not like the setter. The setter changed something about the object. And if you have functions that are doing both, it means that your code is confusing. Another principle related to error handling is that error handling is one thing. So because your functions is doing it, or should do one thing, and should do it well, it should do it only, if you have a function that handles error, this is a one thing. So you should have functions just for error handling, because it is a one thing. Another function or another pattern that is very famous, which is try, don't repeat yourself. Uncle Bob says that duplication may be the root of all evil in software. So to avoid code duplication, you can use some dedicated classes or other forms of abstractions. The latest or the last pattern or point in this chapter about function is that how do you write functions like this? If you paid attention, we have a lot of criteria. We have a lot of points about what characterizes a function as a clean function. And the best way to do it, usually and generally, even for clean code, you shouldn't try to get it right or get it right from the first shot. You should refine it, and you write the function, and after that you read it, you reread it, you rewrite it, and you refactor it, and you massage it in a craftsman vocabulary, and after that you will get to a function that is clean. Now let's talk about comments. Uncle Bob considers comments at best a necessary evil. I remember one time I had an internship in Rabat, I think, with a startup, and I added some comments to my code, and I was happy, my boss was happy, and yeah, it seems like you are doing the right thing by adding your comments, because you are helping other developers understand your code. But if you think or just rethink about why we have comments, you will discover that you add comments because you have a failure expressing yourself using code, because the source of the truth will be always your code. And the problem with comments is that they can change, and when the code changes, comments usually don't change, and people or developers usually don't touch comments, but they touch code. So you can have this kind of non-synchronization between the code and the comments. So here in the Clean Code book, Uncle Bob says that we should strive to avoid comments, and we should try to express ourselves in the code. So instead of having a comment to describe why you have this variable, just give that variable a meaningful name, and we discussed this in the first chapter. But also, just to be fair, there are some good comments, and they are cited in the book. There are legal comments, for example. You have copyright and authorship statements that are necessary sometimes when you are in a professional environment that pushes this. There's also an explanation of intent. Sometimes it is not clear why you did what you wrote in the code, and you provide the intent behind a decision, because sometimes you have a choice between two approaches, and you choose an approach over something else, but you have this kind of intent why you did this, and it's usually hard to explain this in code. There is also one warning of consequences. So for example, if you have a data structure that is not thread safe, so you have to cite this, because people will read your code and they will use it, and if something that is warning that they should pay attention to, most of the time it's hard to have it explained in code. There's also to-do statements or should-do comments. So sometimes we have something that we should do, but we don't have to do it, and it's not a priority, but we should remember its place. So we add what is called a to-do comment. There's also amplification. So sometimes you have something in the code that it seems inconsequential, but it is very important, so you have to just amplify its importance using a comment. Other than this, all comments are bad. So sometimes you add a comment just because you feel you should add a comment, like I did in my internship. Sometimes also this is a redundant comments. You have a code and it's clear, and you add a comment that is probably takes longer to read more than the code itself. Like explaining the algorithm that's used in the code. So here in this function, we do this, and we do this, we do this, and we do this, and then if this, so we do this. This is terrible, because the code should explain this. Also, there are misleading comments. Sometimes, even with the best intentions, a programmer can mislead other programmers using a comment. So sometimes you copy paste a code from Stack Overflow, the crime that every developer commits every day, and you don't really, because you are a junior or you don't have time and you are tired, you don't pay attention to the logic, and you have a great or a high level idea about what the code does, and you write a comment about it. This is terrible, because it's misleading. If someone reads your comment and reads the code, they will have a hard time understanding why you added this comment. There's also mandated comments. This is the comments that are required by processes for no obvious reason. Sometimes, for example, there is a company with coding standard or coding requirements that states that every function should have a comment. This is terrible. Why in the hell you should have a comment for every function? If you have a function that is short, does one thing with a meaningful name, you don't need a comment. There's also noise comments. Some comments that don't add any additional value. So for example, you have let's say list, account list equals new array list, for example, in Java, and there is a comment above this declaration or institution that tells you this is an accounts list. There's no additional values. This is a noise comment. Also, there is also sometimes you have a long test. So you have if this and this, or and this and that, and it is usually hard to understand. If you read a long test statement, it's hard to understand. What you can do here is either you use a variable, a Boolean variable, to store the result of the test and you give it a meaningful name, or there is the other choice, you can use a function that returns a Boolean with a meaningful name. So for example, you have a test for testing if a shipping address is valid. And to check this, you check the zip code, you check the address, you check I don't know, the date or something like this. And this is 3 or 4 statements, 4 checks, and with and or. It's hard, so you add a comment testing if the shipping is valid or the shipping address is valid. This is terrible. You can avoid this by having a Boolean variable that is called shipping is valid. So in shipping Boolean, shipping is valid equal and the result of the test, and you use if shipping is valid. So here the code explains itself. The worst thing about comments, when you have commented out code, sometimes you might wonder, or you might think that you will need this code someday, and you won't be able to remember how it's written, so you just comment it. This is terrible. It's like the problem that we have right now, and the minimalism is trying to address. You have a lot of clutter, you have a lot of things that you don't use just because you think you might use them one day. This is terrible. For one, because we have something called Git, something called versioning. And if you need a code, you can go back and find it. The worst thing also is that if you have commented out code, usually other developers they won't have the courage to remove it, because they will think that this code is too important to be removed. So generally try to avoid comments as much as you can, because they are terrible. I don't follow this advice myself sometimes, because sometimes you need a good comment and you have to admit you fail to explain or express yourself using code, so you go back for a comment. But more comments should bother you. You have to have a code that expresses itself without the need for a comment. Now let's move to formatting. So formatting your code is very important because it's about communication. The first point in the book about vertical formatting, we talk first about the file size. So the book suggests to have small files with 200 lines of code per file on average. The reason is that small files are easier to understand and to reason about. There's also vertical openness between concepts. So here you should use new lines to separate code sections. For example, if you have 4 lines for important packages and you add a new line to separate them from the class body, inside the class's methods you separate variable declaration from the logic. In the logic you separate related parts to make the code more readable. This is what's called vertical density. There are some, you can just have a glance at the code and you understand, or you have an idea about it. So the concepts that are closely related should be kept vertically close to each other. Now for variable declarations, normally variables should be declared as close to their usage as possible, and because our functions are very short, local variables should appear at the top of each function. And also for loop statements, normally you should declare your variables inside the loop statements itself. So while, int, a, less than, whatever. Also instance variables should be declared at the top of the class. There was, I think, in C++ a convention to declare instance variables at the bottom of the class, but usually in Java, Kotlin, and more of the OOP languages, it's at the top of the class. Now let's talk about horizontal formatting. The first point is about line width. There are here many philosophical and ideological arguments and debates about this, but usually we should strive, or generally we should strive to make our lines short, just to make the code more readable. Uncle Bob suggests that we have 100 to 120 characters as a limit for a line of code. Hopefully this limit will be increased as more developers have ultra wide screens for coding. There's also the horizontal openness and density. This is very important. So we should use horizontal white space to associate things that are strongly related, and disassociate things that are more weakly related. So for example, just to give you an example and put you in the context. So for example, you have a variable that you want to increment by a value. Usually, for example, you have a variable that you want to increment by a 5. You write the name of the variable, equal or plus, symbol plus operator, equal, and 5. To make the code more readable, you should add a space between the variables. So you have variable, space, plus operator, equal operator, and white space again, and the operator 5. This is also applicable for most, if not all, mathematical equations. So here you should separate. So for example, if you are calculating delta or something like this to solve an equation, you should separate, because if you don't separate using white spaces, it will be hard to read, even for a mathematician or someone who is familiar with the equations. Now let's talk about another point which is very important: indentation. So indentation is very, very, very important. Without indentation, programs would be virtually impossible to read by humans. And you shouldn't break indentation even for short if and loop statements. So sometimes you have an if statement and you write if and the same line the logic. This is very terrible, because maybe someday we will have more logic in this if, and also sometimes you might make some refactorings and you rename the variables that are used in the if statement or in the condition, and you make the line longer and hard to understand. If you have if, and after this if there is a condition that takes, I don't know, 30-40 characters, and after that there is an assignment for a variable that takes 30 or 70 variables, it makes the code very terrible. So if you have a one statement if or one statement loop, just use brackets and have the statement in a new line. Like this, you won't break any indentation. Usually when you work within an organization or a team, there will be some formatting rules that you should follow, and some organizations go beyond this and add these rules to their IDEs or code editors. Otherwise, you can also use open source rules that are open source and widely adopted in the industry. There are many tools, and you can add them also to your IDE or code editor, or even your CI/CD pipeline. Like in JavaScript there are ESLint, also TSLint. For Go there are Go format. I don't know about Java, but usually you will find some formatting tools that you can use, and just to respect indentation, and you respect usually a horizontal indentation. Now let's talk about objects and data structures. The first point is data abstraction. Here we are talking about a very, very important point, which is hidden implementation. And hidden implementation is not just a matter of putting a layer of functions between the variables. Hidden implementation is about creating abstractions. So it doesn't make any sense to have a private field in a class, for example, and go create a getter and a setter for that same field. Why you should do this? It doesn't make any sense. And most people, when they are learning Java, for example, they never question this. So they create fields, they add private, and they generate getters and setters. And it is terrible, because you have to stop and question, why should I give access to this variable? Why not just making it public or protected or something like this? And here, what you should think about, I remember a very, very good teacher of mine. He was talking about this all the time, and we never paid attention to it. He's sick. I hope he will recover. And he was telling that you should create an abstraction for other classes. So instead of exposing your internal implementation, create abstractions that other classes and other objects can use to interact with your class. So for example, if you have an interface that's called vehicle, and you want to tell the other classes about the fuel state of the vehicle, most people can create let's say getter methods for get fuel capacity in gallons, and another getter for get gallons of gasoline, and you let other classes do the math. This is terrible because first of all, you don't know if the capacity is in gallons, and this is an interface, so you have to make it as generic as possible. And second of all, you exposed the internal implementation of vehicles. So you tell the other classes that every vehicle have a fuel capacity or fuel tank capacity, and they have the access to gallons of gasoline. This is not usually the case. And what you can do instead is just think what this classes or other classes are needing, and create one simple method. So for example, you create a method get fuel remaining percentage, and this method returns double, for example, and tells other classes that this is the percentage of remaining fuel. And here in this implementation, you don't expose the internal. You don't know if the vehicle has a fuel tank capacity, or whether it's in gallons or liters or whatever else. And also you give access to other classes to just what they need. And this is also can be terrible when you have getters and setters for object instance variables. You give other classes access to update those objects. Other than if you can of course clone it, but either cloning is terrible because it takes time. So instead of dealing with all this mess, you can just think about the logic and why you should expose something to other classes. Another point, which is data object anti-symmetry. So here Uncle Bob just make the separation that you can't always have this data abstraction. You can't always hide implementation, because sometimes you have an object when you have a class just to expose data, like we talked in the example of multiple arguments, and you use a class just to group arguments. Instead of passing 4 arguments to a function, or 5 arguments to a function, you create a class that groups these arguments. And here we should have the separation between data structures and objects. So objects usually hide their data behind abstractions. This is the first example that we talked in the vehicle example. And when they hide their data, they expose functions that operate on that data. But for data structures, they expose their data and have no meaningful functions. So again, objects hide their data behind abstractions and expose functions that operate on that data, but data structures expose their data and have no meaningful functions. So you should know where to use each type. For example, for grouping multiple arguments, you should use data structure objects. For, like we said, business logic objects, or business logic classes, you should use objects. And the code that is using data structures normally makes it easy to add new functions without changing the existing data structures. And object-oriented code, on the other hand, makes it easy to add new classes without changing existing functions. The complement also is true. So procedural code makes it hard to add new data structures because all the functions must change, and also object-oriented code makes it hard to add new functions because all the classes must change. Because you update an interface, you should update all the classes that implement this interface. You should just have this separation in mind, and doesn't mean that, for example, when you talked about procedural code that relies on data structures, it doesn't mean that you cannot have procedural code in an object-oriented language. So you can have procedural code in Java, and you shouldn't make this confusion between procedural code and procedural programming language. They are both different things, and just having the separation in mind is very helpful. And the worst thing that you can have is a hybrid class. So sometimes you have half objects and half data structures. Some classes that have some behavior and a very meaningful functions, but also they expose the internal implementation. This is terrible because it makes the class very confusing. You can't reason about this class or this entity very easily, and you need just to understand this and have this separation. Objects expose behavior and hide data. Data structures expose data and have no significant behavior. Again, objects expose behavior and hide data, and data structures expose data but have no significant behavior. Now let's talk about error handling. So clean code is readable, of course, but it should also be robust. And here are some of the recommendations that are targeted to Java, but you can also relate if you are familiar with other programming languages. And yeah, this is a little bit of the unfortunate points about clean code. It relies, or examples always are in Java. Sometimes it's hard for someone from JavaScript, Python background to understand and apply this kind of principles and examples. Okay, so let's start with the first point of error handling for clean code, or clean error handling. The first one is use exceptions rather than return error codes. So the argument here is that you can forget to handle an error after the functions returns its code, but you can't do that with exceptions. And this is a very, very valid point, because the compiler usually requires exceptions handling. So you either add explicitly throws an exception, or you add a try-catch block. And talking about try-catch, you have to write your try-catch finally statement first. This is very useful because it helps you treat try blocks like transactions, and you see the workflow when something goes wrong. This is very important. So when you write your try catch finally statement at first, you just envision what could go wrong, and you have a workflow to how to handle it. The third point is that you have to provide context with exceptions. So create informative error messages, pass them along with your exceptions, mention the operation that failed and the type of failure. This is valid even if you don't have exceptions. For example, if you are in Golang and you return an error or you panic, you should panic using a very useful error message, and also mentioning the method, or sometimes even the arguments that are failed. Just you have to pay attention sometimes to expose the internal implementation when you have an internal server. So for example, if you have an error and you return a 500 error to a web client, normally you should pay attention to what you return. Sometimes a lot of people return the internal implementation to the end client. So you have in the HTTP response, you have the method at line 50 failed. This is bad. If you have a hacker, yeah, they can reverse engineer your program, and sometimes this can cause some problems. Another point is that define exception classes in terms of colors need. So when we define exception classes in an application, the most important concern should be how they are cut. So what was the colors need? And for example, an example from Java, I think, is number cast exception or something like this, because I didn't code in Java for a long time. So I think there's this kind of number cast exception or number something like this. There's also file IO exception or something like this also. So here this naming of classes is very clever, because you see that the exception is defined according to the colors need. Another point, which is don't return null. All it takes is one missing null check to send an application spinning out of control. This is from the book. Yeah, so instead of returning null, throw an exception. You will forced, or the color will force to handle the exception. Or sometimes it's hard to return an exception, or you don't want to bother clients with dealing with exceptions. You can return what is called a special case object. I think it's called like this by the first time by Martin Fowler. So it's an object that handles one special case. So for example, instead of if you have a function that creates a list, so instead of returning null, this can cause problem, you return an empty list. This won't break the colors code, and at the same time it doesn't return any wrong data. It's an empty list. Another point, which is don't pass null. This will prevent the function from checking from null, and you won't have this if this doesn't equal null and all this useless checks. Try to not pass null, and if you have a null params, you just check for it on the colors function or on the colors code, and you don't call the function if the argument is null. Okay, let's talk now about unit tests. In the book, Uncle Bob talks about TDD, test-driven development. I won't talk about it in detail in this podcast, but basically it's a practice invented by Kent Beck, the inventor of extreme programming, where programmers write tests and production code at the same time. This helps you write more cleaner and robust code, because you will have tests that are covering almost all the lines of production code. Now let's go to other principles about testing beyond TDD from the clean code. So the first one would be how to keep tests clean. Uncle Bob argues that if you have dirty tests, it's equivalent, if not worse, than having no tests. So the problem is that tests must change as the production evolves. So the dirtier the tests, the harder they are to change. And if you have dirty, so here the argument is that if you have dirty tests, a bad written tests, it would be hard to change them as the code or production code evolves. And when it is hard to change tests, sometimes people or programmers comment these tests, or they are taking a lot of time just to get some feature to production. And here another point is that tests are enablers. So if you comment your tests or if you don't keep your tests clean, you will lose code flexibility. Programmers will have a fear of breaking production, and the higher your test coverage, the less your fear. If you have more tests, you won't fear changing something, because you know that your tests will catch the bug or catch the problem before it went to production. And some thing about clean tests is that you should keep your test readable, and to make your test readable, the same rules apply as other production code. You have to make your test clear, simple, and dense. And also there are this kind of debate between the single assert per test and the single concept per test. Uncle Bob is with the single concept per test, which means that each test should test a single concept in each function. So we don't want long test functions, because as the same thing as we have in code, production code, we should make sure that our functions are short and do one simple thing, do it well. For cleaning tests, also there is the first rule. The first is an abbreviation of fast, independent, repeatable, self-validating, and timely. So fast. Tests should be fast. They should run quickly, because when tests run slow, you won't want to run them frequently. That's a very valid point. If your test takes 10 minutes, you won't run them quickly. And I have a very, very personal story about this. We had a repo that takes almost 30 minutes to build, and we had, I think in Travis, we had some 2 concurrent builds, and it was slowing all of us down, and it was bad. It is a little bit harder to prevent, because when you have multiple tests, it's hard, and even sometimes you have end-to-end tests, it's even harder. That's why a lot of software engineers advise to not use end-to-end tests and replace them by either unit tests or integration tests. Yeah, it's a little bit tricky to get this fast point. The second point is that tests should be independent and should not depend on each other. One test should not set up the conditions for the next test. So when tests depend on each other, then if the first one fails, it causes like a cascade of downstream failures, and it will be harder to identify the source of the error or the test that failed first. The third point is repeatable. So tests should be repeatable in any environment. You should be able to run the tests in production environment, in QA environments, in your laptop, in whatever environment. And also the fourth point is Tests should be self-validation, meaning that tests should have a Boolean output. Either they pass or fail. You should not have to read a log file to tell whether the tests pass or not. And the last point is tests should be timely, meaning that they need to be written in a timely fashion. Should be written just before the production code that makes them pass. If you write tests after the production code, then you might find the production code hard to test. So here, going back to the TDD principles, if you write your production code and after that you have a dedicated time just to write tests, it will be harder because the code base will be bigger, and the best approach will be to have this test-driven approach to write tests. Now let's talk briefly about classes. The first point is that classes should be small. And because now we are functioning or measuring functions by counting the physical lines, with classes we use a different measure. We measure or we count responsibilities. Normally, if you cannot derive a concise name for a class, if you cannot name a class using a concise name, usually it's too large and it handles more than one responsibility. And the more ambiguous your class name, the more likely it has too many responsibilities. For example, if you have a class named processor or manager, this is really an indicator that this class has a bad aggregation of responsibilities. Here we are talking about a principle called the single responsibility principle. This principle states that a class or a module should have one and only one reason to change. And to organize our classes to change, we have to reduce the risk of change. And we can achieve this following what we call the open-closed principle, which states that a class should be open for extension using inheritance, for example, but closed for modification. So when you create a class, normally you should have the ability to inherit this class and extend and create new functionalities, but normally you should not have access to update it and change it. If you have an ideal system, normally you incorporate new features by extending the system, not by making modifications to the existing code. This is useful because if you have a class, for example, that wasn't changed in a release, you can identify the source of the problem very easily because you added a new class for this feature or a new interface or something similar. But if you have four classes that changed whenever you have a new feature, it's gonna be hard to identify the source of the problem very easily. Now let's talk about concurrency. I think every software engineer or programmer agrees that writing concurrent code is very hard. This leads us to the question of why having concurrency at all. The question or the answer to this question is that concurrency is like a decoupling strategy. So it helps us decouple what gets done from when it gets done. But at the same time, we know that writing even nasty concurrent code or concurrent code that works is very hard. So writing cleaner concurrent code is so much harder. Now here in the book we have some principles. The first one, like we talk the classes, is the single responsibility principle. So you should keep your concurrency related code separate from other code, and also you should limit the scope of the data. Like you limit the data or the amount of the data that is shared. Golang does a very good job at this using Go routines and channels. You have also using copies of the data, so you clone the data. So it's like to avoid shared data, you can just avoid sharing the data at the first place. And one way to do this is just to clone and copy the data. Also, threads should be as independent as possible. and you have to partition or think about partition the data into independent subsets that can be operated by independent threads, and possibly in different processors. Also, some languages does this natively or in a very better way, like I said, Golang, and but Java usually it's harder because you can um, you can miss something and have not independent threads. Also, you should know your library because several libraries are not thread safe. For example, in Java, there are a lot of libraries that are not thread safe. I think there is a package that that is specialized in concurrent code. I don't remember. I think Java Uchil concurrent or something like this. So you should also keep your synchronized sections small. You should get your non-threaded code working first. So if you have code that you are trying to add concurrency to it, first try to have tests for this code in a non-threaded way, non-concurrent way, because if you try to find, if you are trying to find bugs in a threading or in a concurrent code, but you are not even sure that this code works without any concurrency, you will have a really bad time. And you should make sure that your code works outside of threads and outside of concurrency. Another point that you should make your threaded code pluggable, or your concurrent code should be pluggable like this. You can reuse it. You should also make your threaded code tunable. This is for tests. You have to have some parameters for your threaded code, like the thread pool size, and partitioning of the data and things like this. You should also, on the testing, run with more threads than processors. This is very useful to encourage what we call task swapping. And the more your tasks swap, the more likely you will encounter code that is missing a critical section, and that is causing a deadblock. And this kind of bugs is very hard to identify using a very minimal number of threads because you don't have so much task swapping. And another point is that if your test fails for any reason, do not rerun the test trying to make it work. This is a very terrible habit. If your test fails one time, you have to find the reason. Do not rerun the test because you are lucky to find a problem in a concurrent code, which is very hard. Also, try to run your threaded code on all target platforms. Why? Because most or different operating systems have different threading policies, and each threading policy or each change in the threading policy can impact your code, and this can help you identify some concurrent or concurrency problems related to your code. So that was it for today. I think Clean Code is a very, very useful book. If you have time, if you have time to read this book, go read it. If you don't have access to the physical copy, you can check or search for an electronic copy, digital copy, Kindle or something like this. It's available in a low price. This code is very useful because it remembers you of the ideology behind Clean Code, some principles, some very, very important principles. Even if you are a senior developer or engineering manager or something like this, remembering these principles is very useful because you can end up just remembering slogans without remembering details. And just revisiting a book like this, because it's a classic. I think it's a classic in the software engineering industry. It's a classic to read or reread Clean Code. It's a classic book. It's a very important book. I hope this was a very educational podcast for you, and because some people, I might be one of them. I don't really learn a lot from reading books, and don't, even if they like reading, they don't learn technical subjects or complicated technical subjects from books. They rely on videos, and they rely on other sources of information. And I think the podcast, I hope this podcast will be another tool for you, and another way for you to learn about this subject of clean code. I tried to have everything important that I apply, because I ignored something that I don't relate to, even either because I don't use Java, or because it's, you can say, outdated. And I try to keep everything that is important and crucial. And I encourage you to revisit and re-listen to this podcast, because the principles are priceless and timeless. Also, you have to excuse me for my pronunciation. I didn't talk in English for a very long time, because of I didn't talk in English for an extended amount of time, a long time ago, because of the pandemic. I didn't give some speeches, or I didn't participate in some public speaking meetups, or something similar. Even at work, I'm working remotely, and my meetings are mixed between English and Arabic. So excuse me, the pronunciation, and my English pronunciation will get better if I'm doing more podcasts like this. And hopefully we will meet next week on another video, podcast with a guest, or podcast like this. As always, take care of yourself, and salam alaikum.